Good morning. You feel better?
I do feel better. Thank you for asking.
Maybe it was just allergies.
I hope so.
Do you take allergy medicine?
Yeah.
Anyone else in apes? What is that? Oh, soil lab? Yeah. This is my soil. I dug it up in my backyard last month. Okay, that's what I did.
Oh, that's like actual soil?
Yes, you got 8 bug bites.
Oh my
Are you
gosh, I thought this
serious?
was like, I thought this was like Oreos.
Did you have to do that? Oh no, girl, I had a shovel in my backyard last month.
That's fun.
Wait, what did you have? I have 7. But the lab is next week, I think.
Okay.
I didn't actually read the whole lab, I just read that we need how to have soil.
Measure it out, put it in a little.
I need to write down the answer on it. I'm not sure how I can feel like soil.
Yeah, that looks like solid seed.
I'd be upset. I worked for that soil.
How dumb, how deep is it?
Look at these bug bites. I got one bite. It has to be 3 inches. Bro, only 10 minutes. There is some hard soil in my backyard. Rocks. I was
Yeah, I know. I don't think I'd be able to.
It can't be from like it can be from a flower bed or a flower pot. So it has to be 3 inches under the grass. I was doing it.
I did too. I should have nothing to do during that. I don't know. I know. I just said. Hey. In
You said what? Did you say?
What the pandas? Yeah. We like tried to see the
Calculus.
what are we supposed to like?
We did 10.
Did you say that you?
Oh, I don't either.
I took it last night.
Okay, good morning. There's a handful of assignments I need y'all to dig out of your binder. 11, 12, and 13, please.
So, well, let me go ahead and get attendance put in. Oh, you don't have to turn anything in today.
If we need to turn in stuff from past classes.
Just put it in the basket over there. Okay, while you guys finish getting those 3 assignments out, let me tell you kind of the plan for today. So there's really three big hurdles for us, boys. The first is I want to make sure that you had a chance to ask questions from assignment 12. That was one you guys worked on last time, but I don't think you got all of your questions answered before you ran out of time, because because not everybody finished it. So I'm going to offer that first. Second big thing you need to achieve today is you need to finish working through the review, because I had suggested you work some of it. How much depends on how comfortable you are with this. And I need to, 3, help you with making sure that you're good with all of the stuff on the review. So most of class today will be giving you time to work on the review and helping you with the ones that you struggle with on the review. But also keep in mind that our first quiz is coming up next class now. So sometimes with you guys being the B-Day, sometimes you get gypped a little bit of time, sometimes you get extra time. This one you get extra time because tomorrow's an A-Day, so I don't see you again until Tuesday, so you happen to get a little bit more calendar days to study if you need to. Sometimes I'm going to see you on Thursday, and then I'm going to see you right again on Friday, so occasionally you have less turnaround time than an A-Day class, but this time you've got more, so just make sure you take advantage of that opportunity. Second, I don't remember if I had mentioned, but I refer to this as a quiz. I know to y'all, you sometimes care if it's a quiz or a test. It doesn't really matter too much. In gradebook, it goes in as a major grade. I refer to this one as a quiz because it will be a 20-point assignment, whereas most of what I consider tests will be 50 points assignments. So it's really just less points why I'm calling it a quiz instead of a test. You should expect it to be around 10, 11 questions and a free response. Some of the questions might be multiple choice, some of them might be fill in the blank. I guess one thing to consider is our quiz on Tuesday will be the first major grade of the semester. So again, most of our tests this semester will be 50-point major assignments, and this one's only going to be a 20-point major assignment. So at the end of the semester, this one won't weigh that much compared to the others. But temporarily, as soon as you take that on Tuesday, it's going to be the only major grade in the grade book, and that's 60% of your grade. So temporarily, this quiz will be worth more than half of your grade. Okay, and then last thing before I start trying to help out here, I have on the agenda so I wouldn't forget, but late work reminder. Remember, I do take late work for half credit, or I'll take incomplete work if you finished it to get half of your points back. The only stipulation I have is that it has to be done before that unit assessment. Since our unit assessment is on Tuesday, the very start of class on Tuesday, if there's anything you didn't do, your last chance to finish it all and turn it in before the quiz is needs to become homework now, because this is your last chance. If there was anything you got half credit on because it was incomplete, you can finish what you didn't do, get half of your points back, but I have to have it before we start the quiz. Not the same day as the quiz, not later in the same class period as the quiz. I want it before the quiz. I want to see that you put in that extra effort before. So you're always welcome to put those in Google Classroom, or you can just give me the hard copies before we start. But if that applies to you, you need to add that to your homework list. Okay, so I haven't gotten a ton of questions from assignment 12 from my other classes, but I did want to give you guys a chance because, again, some of you guys were finishing up this assignment 12 last time, and so you might have needed some help on a couple. Of course, any of this stuff would be fair game for the test, so don't be dismissive. Don't just copy the answer down from the website. That might help you get the homework points, but the homework points aren't going to mean as much if compared to the test points. So this assignment 12, is there anything from it that you need help with? Yeah. 12 on 12. Okay, so if you don't need help with this one, take a couple minutes, work a few more questions from your test review. Again, I didn't say you had to have that finished, so you probably have a page or two left of it, so you can work a few while I help out with this one. Okay, so this particular assignment was about types of discontinuities, and so we were trying to figure out where this function would have holes and where this function would have vertical asymptotes. Now, somebody asked in second period today, for types of discontinuity, can I just say hole or vertical asymptote? And the answer to that is no. Saying there's a hole here or saying there's a vertical asymptote here is a good way to describe the graph. Those are not types of discontinuities. Types of discontinuities would be removable if there's a hole there, infinite if there's a vertical asymptote there, and jump if the limits are not equal at a point. So regardless of which of those you're talking about, you really want to think of this function as a big fraction. So cosecant is the same thing as what over what? Not cosine. 1 over sine. So cosecant of x over 2 is the same as 1 over the sine of x over 2. So again, those of you who skipped pre-cal, there are a handful of trig identities. This is one of them. You have to know the reciprocals. Okay, now that this is written as a fraction, I know how to work this out because I know if there's any number that makes the numerator and the denominator 0, it's a whole. So I can say there's removable discontinuity there. And if there's any number that makes just the denominator equal to 0, that creates a vertical asymptote, which means it is infinite discontinuity. So I will be able to answer that way. Now, the nice thing about this is we're not going to have to spend any time on the numerator at least. 1 never equals 0. So there's no numbers that are going to make the numerator and denominator 0. So if there is no holes, then there is no removable discontinuity. So I don't have to put too much thought into knowing that. But this denominator probably equals 0 at least one place, probably many places. So to solve this, what you need to do is pretend like this says x for a second so that you can use your unit circle knowledge and say sine is 0 at 0 and pi. But the first answer, I'll say x equals, the first one is 0. If you add pi, you get this one. If you add a second pi, you get this one. If you add a third pi, you start getting coterminal angles. So I would say the solution to sine x equals 0 is every integer multiple of pi. 0 pi, 1 pi, 2 pi, negative 1 pi, negative 2 pi, negative 3 pi, etc. You just need to be careful to realize, wait, I didn't have x here, I had x over 2. So over here, x over 2, I've got to do one more step to actually solve for x. Or the numbers that make that true. So I need to multiply this side by 2, which means I have to multiply that side by 2. This is like the formula that tells you everywhere where that equals 0. Okay, so I'm going to try to read this. N could be 0, so that would be x equals 0. N could be 1, which would be 2 pi. N could be 2. I'm just plugging in integers for n. N could be 2, which is 4 pi. And why should I probably stop here? Right, this says only worry about numbers between 0 and 2 pi. 4 pi is already outside of that. And then 99% of the time you include 0 or 2 pi, but not both. This one actually says include both. So these are the two times that the denominator equals 0. When the denominator only equals 0, it's creating vertical asymptotes. But the calculus answer is that is where we would get infinite discontinuities. Is that okay? And unfortunately, that's just harder. Solving a trig equation is not the easiest thing to do. That's why we spend a week and a half on it in pre-calculus. It's good for you to practice it, but luckily I can't say that I've ever seen a released AP question where they expect you to do all of this. So I wouldn't stress out about that. But you still need to put in good effort during class. Okay, anybody else have the same question about 12? Want to ask something more detailed before I move on? Okay, what else do you have on assignment 12? If anything.
Did you talk about number 15?
Did I talk about number 15?
Yeah, did you?
Oh, sure, I can. You use this graph up here, right? Yeah. Okay, question 15. On what interval is f continuous? And so we're supposed to be up here using this for question 14 through 16. And this is the graph of f of x. That doesn't seem important right now because you basically have never seen another graph, but that's going to be important as we move throughout the semester because we're going to also look at derivative graphs and second derivative graphs and stuff like that. But this is the original function. So it wants us to state where is it continuous. So I need to state the times where it does not have breaks in the graph. So I would say right here from -3 to -2. All the answers have that though, so that doesn't narrow down my choices. And then it's continuous from -2 to 0. Now, how come I'm doing parentheses and brackets? Why did I do parentheses on -2 but a bracket on 0? Okay. I heard you guys, but I didn't understand any of that. So I'm going to assume you said negative, you can't include -2 because there's a hole. You have to include 0 because it's filled in. So that throws out choice A because it had brackets on both. It throws out choice D because it had brackets on both. Okay, if we keep going, this next little segment, actually the whole rest of it, looks like, is from 0 to 2.5. Okay, should I include 2.5? Yes, because it's a filled in circle. Should I include 0? No, because it's an open circle. So you pair up all of these as continuous during this time, and during this time, and the only one that has all of that correct is choice C. Okay. Anything else for assignment 12? Okay, so I didn't address this to the whole group, but you guys can see I didn't ask for any assignments to be turned in today. I guess in theory I could have asked for assignments 11 and 12 today. Those should be finished now that I just took your questions from assignment 12. But even though I tend to do a good job of taking your homework papers, if they're participation grades, scanning them, put in the score, and giving them back to you in the same day, sometimes I can't do that. And that's more important today because if I take up your assignment 11 and 12 right now and I don't have time to grade them and get them back to you, then you don't have them to look at and you might need them to study with. So that's the only reason I didn't take them up yet. I will be taking them up before the quiz. In fact, 11, 12, and 13 can all go in the Google Classroom as soon as you're ready to do that. I know a lot of you already have, but just giving you a heads up there. Okay, so let's move in to the bigger part of class, which is going to be about the test review. Now again, I gave this to you last time. I asked you to do some of it for homework, and I had suggested that it be proportional to how prepared you felt for the quiz. If you feel like you were ready to make an A or a B last time, then just doing a little bit of the review is probably fine because you don't have too many things you need to clear up. If you feel like you're starting to drown, you should have done most of the review. That means you have plenty of class time to finish it and plenty of time to ask all the questions you need to ask to get all the help that you need. So another warning I need to give you is that I do not take questions on quiz days or test days. A lot of times students will come in and they'll just have a quick question or two. I can't answer your quick question or two because if I let you ask a quick question or two, there might be 10 other people that want to ask that. And then next thing you know, it's 30 minutes later. So partly I don't want you to procrastinate, and partly there's no way for me to do that in an adequate way because people who come prepared should get their normal time for the quiz, and if I let there be 30 minutes of questions, then that's not going to happen. So I don't do that to be mean to you, but I'm forewarning you to make sure that you ask the questions you need to ask today. Don't kick them down the road and then just try to ask real quick before class on Tuesday. Okay, so again, I know you haven't finished this, but you should have done some of it, so there's a good chance in you starting to scan some of these questions, you might have realized that some of these are ones that you need help with. Now, I will record any unique questions that you have, but between my third period yesterday and my second period this morning, we have a lot of these on the website already. So I recorded questions 2, 8, 9, 10, 14, 18, 19, 21A, 21B, 23, 24, 25, 26, and 29. So you guys are also welcome to ask those questions. During class, you're welcome to ask whatever you want to ask. But there's a whole lot of the ones that the other classes have asked that are already as individual videos on our class website. So if you, for some reason, don't get to them in class, even though you should, there's still some help for you outside of class from me. Okay, so is there anything that you have found from the test review that you know you're going to need to ask about? Yeah.
Could you do 2?
Question 2E. Sure. Okay, so 2E wants us to figure out what's the limit as x approaches negative infinity. So where is that in the graph?
Sorry. Oh wait, do we use the graph or the chart?
Well, if you're talking about question 2, it's
I'm
the
thinking
graph.
about 3. Sorry.
Okay, no, that's fine. That's fine. So question 3E. Okay, yeah. So the table questions are sometimes a little harder to feel confident about because the table is giving you only a couple values to work with. And so to be honest, with many of these, you just have to estimate. I don't really know what's happening between these two values. Between this almost -4 and almost 2. I have no idea what's going on. I have to make educated guesses. But 2 from the left, so if you're coming from the left of 2, that's when x is slightly smaller than 2. Remember, limits could care less what's happening at 2, so if it helps, just ignore that. But this is as close as I can get as for 2 from the left, right? You okay with that part? Okay, so what y value does it look like it's approaching to you? If this is where it's almost 2 and this is its current y value, what would you guess it's going to be when x is 2?
Like -4,500.
That's a fine guess. That is a good estimation. If this is almost -4,500, if you inch over, there's a good chance that could actually be the answer. It could also, you see how this is a very, very, very negative number? It could just be shooting down to negative infinity, which, or you could say does not exist. So any of these 3 answers would be fine on free response. As a multiple choice, it's either going to put this, this, or this. It wouldn't put more than one, because any of those make sense.
Okay.
It's just an estimate, and if that's what you think the estimate is, that makes sense, so that would be fine. I tend to think that, I mean, again, there's no way to know. I just know that's a really small number, so I'm just guessing it's shooting straight down to negative infinity, personally. Okay, I saw another hand a minute ago, and I forgot where it was. Okay, John?
Could you do 4?
Sure. Okay, so question 4 is about evaluating a limit from a piecewise function. So, same idea, but piecewise functions are obviously not your most comfortable question type. So what you really, really, really have to do in your head, the part that you're going to be in trouble if you forget, is if you want to know a limit question, at least in your head, you need to be asking, what does it approach from the left, and what does it approach from the right? because if these two are the same, then that's the answer to the question, and if these two are different, then the answer would be does not exist. So you got to pay attention to these. This is saying 2 from the left, which is where x would be less than 2. So you're going to direct substitute 2 into all of this stuff and get 12 minus 6. And then 2 from the right would be when x is a little bit bigger than 2. So you're going to plug it into this part because this part is when x is bigger than 2. And you get 7 minus the cosine of 2 pi over 3. And the cosine of 2 pi over 3 is 1 pi over 3, 2 pi over 3, cosine's the x value. Negative 1/2, there you go, negative 1/2. So that ends up being 7.5. And these two are not the same, so the answer is what?
Mr. Thompson, is approaching from the left 8 instead of 6? 12 minus 4.
Yeah, it should be 12 minus 4, so that should have been 8. So I messed up the arithmetic, thank you. But I would have still gotten lucky because the limit from the left doesn't equal the limit from the right, so it doesn't really matter anyway. The answer would be does not exist. But you've got to be very careful that you're looking at and reading this carefully, because question 5, if you oversimplify this and say, oh, all I did was plug in 2 into this, get a number, and plug 2 into this. That's the approach sometimes and not other times. You take that approach on question 5, you're going to miss it. Okay, I think I also, for what it's worth, I did do this answer key yesterday before school in about 15 minutes, so there probably will be a couple typos. I think right here I said minus originally, 7 minus 1/2, so the answer key probably still says that. I just haven't rescanned the solutions in yet, so yes. 3E? Okay. John, that was enough. 3E. We already did 3E. We already did that one. Okay, others from test review? Yeah. 19? Okay, 19. Determine if the function is continuous using the definition at the given x value. Now, to be honest with you, when it says using the definition, that's really just there as a hint. Remember, there's a definition. It doesn't have to say that at all, but that's what your thought should be. You should say, okay, there's 3 things that have to happen for this to be continuous. There better be a point there. The point needs to exist. So if I'm trying to figure out what y is when x is pi, you should plug it into the top part, because this is when x can equal pi. And so when I plug pi into this, I get e to the pi times the cosine of pi, and the cosine of pi is -1. Thank you. Unit circle. So there's the first part. I showed that there's a point there. Second part of the definition, whether it was asking me to do definition or not, I'm going to do it anyway, is I need to make sure the limit exists. So what does f of x approach from the left of pi versus the right of pi? So this goes back to John's question a minute ago. Trying to figure out what the limit is here to make sure that this parts connect. So from the left, you need to plug it in when x is less than pi. And when you plug it in here, you get e to the pi times the tangent of 3 pi over 4. And the tangent at 3 pi over 4 is -1. From the right, x needs to be bigger than pi. I plug it in here. I get e to the pi times the cosine of pi, which I actually did over there a minute ago, so I don't have to do that in my head again. But now I have shown the limit exists. It approaches the same thing on the left and the right. The last thing I need to be concerned about is that the point f of pi, which was equal to this, is equal to the limit, which was this. So the point's there, the limit exists, and the point equals the limit. So I did all of that to give an answer of yes, it is continuous there. So if it was just a yes or no question, yes is it. But if it said justify your work, you would need to show all three parts of that. Point exists, limit exists, point equals limit. Okay, was anybody else going to ask about question 19 while it's up there? Okay, what else do you have from the test review ready to go?
You do 10.
Let's see, 10. Yeah. And every class has asked about question 10, and I think they understood it after I talked about it for just a second. So that's a great type of question to ask, one that doesn't take too much work to clear up. Okay, before I go over question 10, this is just how I like to structure these things. I'm just giving you a heads up because you'll see this a few times throughout the year. But basically, I have these things kind of sectioned off. You can see that this is reminding you that you need to know the intermediate value theorem, and it's just having you practice a couple questions to kind of help you test if you remember that. I've got where you can look it up in your binder if you need to see some notes or examples. And then over here, this blank, you don't have to use this at all. But me personally, I like to check stuff off as I'm sure I'm good with it. And I like to leave it blank if it's something I still need to study. That way, if you guys check off half of these, when it comes time to study, you know which question types you're good with and which question types you still need to look at. So that's what these little blanks are for. Okay, so intermediate value theorem just tells us that if you have a continuous function, which this is, because this is a polynomial, polynomials are always continuous, then it has to hit all of the y values from the starting y value to the ending y value at least once. Now, unfortunately for this, there's no way to work with this and then see the answer. You have to do guess and check. So I'm going to guess A, and I'm going to ask myself what was its starting y value and its ending y value. And if I plug in -2 into this, I get -45. I did this arithmetic earlier, so I'm going to go over that part pretty quick just to save time. And then if you plug -1 into that, you get -19. So all extreme value theorem is guaranteeing is that it hits all of the y values between those two. So does that mean it has to hit 0 between -2 and -1?
Yes.
It's going from -45 to -19. Then no. That was your only other guess. So if we only know it hits these y values, it might hit others, but IVT only guarantees I hit all of these y values at least once. 0 is not a guarantee. So unfortunately, A was not it. So now I've got to guess B. Think about his starting and ending y values. 8 minus -3. And if he starts at a y value of -11, ends at a y value of -3, IVT is telling me it hits all of the values between them. But I'm trying to figure out one that equals 0. This doesn't guarantee to hit 0. So can't be B. So I can try D. Starting y value, I already did that over here, so I can reuse that information. Ending y value is easy to solve. What about this one? Does this ever have to equal 0? No, it has to hit everything from -19 to -11, which is not 0. So of course, if you're low on time, you've narrowed it down, pick D and move on. But then if you have more time on a test or a quiz, come back and make sure that it actually works and that you didn't have a small mistake in here. Starts off at -3. This one ends at 23. So if you're going from below the x-axis to above the x-axis, at some point it's crossing the x-axis when y equals 0. So that's why D works. But you pretty much just have to do guess and check. Try one, see if it works. Try another, see if it works. Now, somebody in second period today also had another good point. Their work was this, and you see if you can tell what their mistake was. They did this, and then they solved it for some decimals. And what is it? What is this that they're doing here? Okay, and quadratic formula only works on quadratics. So part of it is that some of this just doesn't print off great. But notice this isn't a quadratic. That's why that wouldn't have worked there. If this was a quadratic, then technically you could solve it, and then I guess you would know what values equal 0. So that's not likely to come up though, because then you wouldn't be doing any calculus. Okay, anybody else that was going to ask about 10 need to ask something more detailed about it? Okay. All right, what else from our test review, quiz review? Okay. Sounds like you need a few minutes to work. So what I'm going to do is I'm going to set a timer. I'll wait about 10 or 15 minutes. You should have a handful more questions completed, and then I will interrupt you and offer to work another round of questions. And then we'll just rinse and repeat as much as we have time for today. So go ahead and pick up wherever you left off last time. And I will stop you in just a bit and try to help.
Which now I know is Jack London, but at the time I was like, I didn't know it's fake. The fake one is like, how do you know this? He asked us what his weight was. No.
Well, I forgot to sign up, so.
I mean, I get that too.
Yeah.
But I was like, what the hell is you and that?
Making like answers and all of this on the 10 quiz. We got this from the answers and I was like, oh, you're just like, okay. If you go, I'm so sorry. I got pickles for like thinking about something. And my soil.
Someone okay?
What's the word? Like I thought. I don't know. There's a lot in my backyard.
Everyone okay? Okay, good. What you need to do, before you do direct substitution the second time though, you need something to cancel. So you need to realize that you can combine these, and plus 5 minus 5 just goes away. And then you've got just the x on top, and on the bottom you've got x times, so you'll be able to cancel out the x's and then do direct substitution. Those are equivalent. This is a little bit better, just because negative exponents are typically considered. More often than not, you have to take the negative exponent and take it.
How many nodes approaching -1?
Or 14 maybe? I don't
How do you know
understand.
this?
No,
And
they're
that's as far as I can get to the left.
yeah.
And
They're
then
long
infinity,
ones.
you want the smallest X size you can.
Oh, so it's.
And it just looks like it's getting close
No,
to
for
the
her.
other one, but that's my
Not that one. For that. Wait, is that one question? Stop. Oh, my bad. My bad.
No, but I don't know what you're supposed to do.
No, but
I don't know what that means.
this is- this is as far as like it
As
goes.
negative goes to
It's so
infinity, or
like
as it
easy.
goes to infinity.
It's
I don't know if it's gonna be different as it goes to negative.
It looks like
It's all good, I got it wrong, so. Oh, it's on here, it just says negative 5 now, so I don't know if you.
That's all right. Hey, look at us.
Smart or whatever.
What can we say?
Guys back here.
Wait, who is that?
Oh, yeah.
Oh, do you know? I'm so upset we didn't get our.
Yes, I got assignment. No, we didn't get, oh wait, we didn't get out. Oh, yeah.
Why do we keep doing it? No, but I know exactly what.
I know.
I was so disappointed. It's because
Yeah, we did by the red exam every time we said.
Yeah,
Yeah, I
and it's
think we forgot about
because
that
people
one.
haven't turned in the driving forms.
But we'll find out tomorrow. Yeah.
You want that?
Wait, did we recycle them?
As far as we did.
Well, you just said.
You just wrote it, yeah.
Are we recycle?
Yeah. I don't have to do unless the base. So like,
I know, I walked back with like my huge recycle bucket and no one excited.
Okay, about 3 more minutes, and I'll let you guys ask another round of questions on the board.
Oh, because you.
Also, just a suggestion slash option. No preference to me, but I do try to make a few extra copies of each of these worksheets. Partly because I know sometimes people lose them, and sometimes you guys feel like we need extra practice on them. So I know that there's probably a few of you that would like, not many left. But I do have a couple extra copies of test review. So like, if you feel like maybe you just want to work it all again, that's not for me, but if that seems like a good idea for you, you're welcome to one of those. I've got extra copies of everything we've done, so, I don't know, maybe assignment 7 was the one that's giving you the most trouble. You're welcome to an extra copy. All of this stuff just gets recycled at the beginning of next year anyway, so if you ever want an extra copy of something, then help yourself. Of course, you can also get them off the website if you have a printer at home, so. Okay, before I take another round of questions up here, there's one other thing I want to point out. This might be decent motivation for some of you guys. So whether you're finding the limits unit easy or difficult, you may have noticed on our class website that I asked you to bookmark. I do have this little graphic here, which I've not really talked about much. But this just kind of shows you not free response, but multiple choice part of our AP exam, how much they weight it. So even though we're only in the first couple weeks of school, you can see that these type of questions on limits and continuity are going to make up about 10 to 12% of your AP exam. So that's a pretty good chunk for just a few weeks of school. So again, to me, that seems like that would be incentive to really make sure that you feel like you know that, so that you know, the better you do on the first few units, the less and less pressure you're creating for yourself on the later units. Okay, so which questions? It's been 15 minutes since I last took questions on the board, so is there some others that I can go over to help out? Yes.
18.
18.
Or
19?
19.
We already did 19 together.
Oh, no, yes. 18.
Oh, 18? Okay. Okay, determine if it is continuous. You're going to use the definition whether it says that or not. So let me erase this to get this stuff out of the way. Okay, so if I want to know if something is continuous, I know in my head there better be a point there. So f of negative 3 needs to exist. And if I plug negative 3 into this piecewise function, what do we get? 5. Very good. When x equals negative 3, y equals 5. So the first part of the definition is fine. There's a point. Second part of the definition wants me to think about the limit. So the limit as x approaches negative 3. So I actually need to think about the left and the right limit. So from the left would be when x is less than negative 3. Should I try to plug that into the top or the bottom? Say what? The top. If you're coming from the left of negative 3, remember that's a number slightly less than negative 3. And this is saying use this one anytime x is not negative 3. So if I plug negative 3 into this, I get 0 over 0. You're going to have to do factoring. But you plug negative 3 into that, you should get negative 6. Okay, you should also think about the right limit. Well, you're going to plug negative 3 into the same exact thing, because from the right, x is greater than negative 3, so it's still going to be the top. So you're plugging negative 3 into the same thing, so of course you're going to get the same answer. So the limit also exists. Is that okay? You're all right with that? Okay, and then last part would be that the point at negative 3 needs to equal the limit at negative 3. The point was 5, but the limit was negative 6. Those are not equal, so it can't be continuous. And if it said justify, you would only have to show this last part. You only need to state the part that's messed up to prove it's not continuous. Okay, was anybody else going to ask about 18? Okay. Christopher, do you got a question or two? Nope, not yet. What you got?
23.
Number 23. Okay, so since you asked this and this came up, now as the year goes on, I can give you more traditional type of FRQ practice and FRQs on our test. But early in the year, to be honest, there is no FRQ that they have ever put on your AP exam that is only about limits and continuity. There's just, that's not enough to do a full FRQ. It's surely going to be a part or two of some of your FRQs, but not the whole thing. So for this test, and I can't do this for other tests, your FRQ for your coming up quiz will either be like question 23, like question 22, or some combination of 22, 23. So again, I can't normally tell you it'll be like this or like that, but for this one, I can give you that little bit of a hint. And as we get into the year, usually around your third test, it'll be exactly half your points will come from multiple choice and exactly half your points come from FRQ. And the reason why we do 50-50 like that is because that's how your AP exam does it. So it'll be not necessarily that way the first couple. So I say all that to say that question 23, this is a good chance that your FRQ that may be close to half of your points on Tuesday's quiz could be like this. So we need to make sure that we understand what the process is, because this is a longer question, but it takes very, very, very little calculus to be able to do this. In fact, I'll do the calculus steps in red just so we can identify that. Okay, so in this question, our goal is to try to figure out what is A and B so that this piecewise function is continuous. So A and B are just numbers. Notice this is a polynomial, so he's continuous. This is linear, he's continuous. And this would be linear, he's continuous. But if they're not connecting, where all three pieces are connecting just right, then it may not be continuous. And that's what we've got to do. We've got to find the values of A and B so that they connect correctly. Now, the only two times I really care that they're in the same place at the same time is at x equals 2, because that's where it starts or stops being the top function and starts being the middle function, and at x equals 5. It stops being the middle function and starts being the bottom function. So I want these two to be the same, the top and the middle one, but I really only need them to be the same at one specific time, and that is when x equals what? 2. I don't care what they're doing before 2 or after 2, but those two better be connected at x equals 2, because that's when it stops being this and starts being that. So as soon as you plug in 2 for x, I'm going back and putting in red so that I have that. Okay, I want these to be the same when x is 2. So you go through here and you plug in 2 for x. You're going to get a statement like that. And you can combine some like terms. You can try to clean this up a little bit. You could take away 2 a's from both sides. You could subtract a b from both sides. You could subtract a 2 over if you want to. You can divide by everything by 2 if you want to. I don't know. But the point is, eventually you get down and you realize you don't have enough information to solve for a and b, because you've got one equation with 2 unknowns. We can't solve that. But we've got one other thing going for us, and that's that we know this and this have to be the same. But specifically, we only really care that they're the same when x is what? When there's 5. That's when it stops being this one and starts being that one. So, same idea. Now I can plug 5 in for x. I get a statement that has a's and b's in it. I don't know. We can make it look a little bit nicer by at least combining like terms. But at the end of the day, you end up with 2 equations that have 2 unknowns. You don't know A and you don't know B. Now, luckily for you, this is not something I see on the AP exam very often. In fact, I can't remember a time other than maybe FRQ that this comes up. But do you remember what it's called when you have more than one equation and more than one unknown?
Solving systems of equations.
Good, systems of equations. So even back as far as Algebra 1, you talked about multiple ways to solve this. I'm just going to do substitution. If I know how big B is, I can go over here and put that in place of B. I can substitute that. And the reason why you would want to do that is it gives you an equation that only has a's in it. And after a few steps later, you know how big A is. And once I know how big A is, how can I go about finding B? All right, substitute it again. You've got multiple places you could plug it into. just wherever you think it's going to be easiest. But if a minus b is supposed to be -1, and I now think a is 2, I can solve for b. So it looks like a is 2 and b is 3. Now again, I said when I started this question, I was going to do the calculus part in red, and then the algebra part in black. So the only real calculus piece here is to understand why you're setting these two equal at x equals 2 and why you're setting those two equal at x equals 5. If you understand that, I'm not saying the rest of the question is easy, but the rest of the question is not calculus specific. It's stuff that you have done in the past. So that's where those two answers come from. And then the last part, part B, this is actually the easy part, because this wants to know the limit as x approaches 3 of f of x. So since this is x approaches 3, think about which one of these 3 to pick from. This is the one that's x is 3. But you don't need to say ax plus b anymore. You actually know a is 2. You actually know b is 3. And then you can solve this with direct substitution. 6 plus 3 gives you a value of 9. Okay, so a lot going on there. Let me make sure that you don't have any follow-up questions to that. I'm sorry, I don't remember whose question this was, but is this yours? Is that enough? See what to do?
Yeah, I just did math wrong.
You did the math wrong?
I have
Oh.
-16 over 3 for b.
Well, you probably just try to compare and see where you may have gone wrong with him, I guess. Yeah. And unfortunate, just part of how calculus goes, some questions are nice and quick and take 0 steps to show. Some questions like these, I don't even know how many steps you would count this as being. But even if you can solve systems, even if you understand why to set that up, you're going to learn that you have to be very, very careful. Just because you can do it, if there's 10 steps to the problem, you have to be very diligent and careful. Even if you know what you're doing to end up with the right numbers. So, okay, did anybody else have a follow-up to 23? Okay. All right, is there any other questions you have found? All right, John.
19.
We already did 19. For the second time. I don't mind what y'all work on, but I'm not going to go over the same questions multiple times. So y'all need to make sure that if you need to follow it, then please do. It does. I do have the video on the website though, so you can watch that later. 21A. Okay, 21A. Is h of 2 the same thing as the limit as x approaches 2 of h of x? Well, h of 2 just means you're going to plug 2 into the function. So you would end up with 12. It's like 4 over 3, I think.
That's what I got.
Okay, so that's how you would go about doing the point. To do the limit, well, we'll make this a little bit easier. Don't go back and forth here. If this is the limit as x approaches 2 of h of x, and this is h of x, just write it in here, because this is how you're used to seeing it. Okay, so that makes it a little bit easier. Second, are you asking this question because of the answer key, or just because? Okay, I think I still have a mistake on this one on the answer key. I haven't had time to scan my work back in. Okay, so I know for limits, I'm going to try direct substitution first. Hope I don't get 0 over 0, because I know I've got to do more work there. But if I plug 2 into all of this, what is all that going to go to? It does?
4/4.
It should be 4/3. It's the exact same arithmetic. When you're doing direct substitution here, that's the same as plugging it in and trying to figure out where the point is. That doesn't mean a limit and a pointer are the same thing, but these two are definitely equal. So, are they equal? Yes, and then here's my justification.
Did you, first one, or it's not?
Well, I plugged 2 into it, so I just said 2 squared was 4. I just did that part in my head. Also, for what it's worth, you will not see these exact questions on the test, but I actually stole these questions from some other calculus teacher's test that she uses on the first unit, and that's why this question 21, I forgot to take these point values off. You can see somebody else actually had these as real questions on their test, so that gives you an idea that they're perfectly appropriate. Okay, has anybody not asked a question have one? I'll give you a chance before I let people keep asking more. Okay, does anybody who has asked a question have any others ready to go? Okay, so we still have about 25 minutes, so let me do one more timer. I'll wait about 10-15 minutes, and then I'll take one more round of questions up on the board. And then I'll give you all the reminders that you need to know about for next class. Okay, so that means we've got 15 minutes till you're gone. So for me to have time to answer your questions, I need to start taking those now. So is there anything else you found from the test review that I could help with? Yes. 21 part B. Okay, partly 21B is a little harder because it's still talking about h of x from the beginning. I need my pass back, Brandon.
Oh.
So find the limit as x approaches 1. So again, I'm going to do the limit as x approaches 1 of h of x. To make it easier on your brain, just copy h of x down, especially since it's on the other page. I don't want you flipping back and forth. Okay, so the first part of this, find this limit. So we know to do direct substitution. Hope we don't get 0 over 0. Unfortunately, it looks like we do in this question. So what is the most common way to deal with 0 over 0? Factoring. And if you're asking this question because I think I might have done this one wrong on the answer key. I've corrected it here, but I haven't had time to re-upload it. Originally, when I first worked this, I did not factor this correctly, I think. I did this, I think. Minus 6 plus 1. Maybe not. What did I do? Oh, well, it can't factor like this anyway. Positive 1 times negative 2 is not a positive 2. So, at least the first time I did this, I just factored this first part a little too fast. I was 99% sure factoring was going to be what I needed. So if we do a minus 2 and a minus 1, check it with FOIL. Okay, that's actually okay. So now that it's factored correctly, something cancels as I was expecting it to, and then you plug 1 into the leftover stuff. You get 3 minus 2 over 1 plus 1. So first part of the question would be 1/2. Okay, is this limit the same value as h of 1? So if I try to figure out h of 1, h of 1, look at the function again. H of 1 just means I'm plugging in 1 into this function, and you can do that, but I've really already done that a minute ago. I did that when I did the direct substitution and got 0 over 0. So the fact that plugging 1 into the function gives me 0 over 0 means that I know something's happening at x equals 1. Something visually is happening at x equals 1. What's happening on a graph if you get 0 over 0? Okay, and a hole means that the point does not exist. So I would say h of 1 does not exist. The limit as x approaches 1 of h of x was 1/2, and does not exist is not the same thing as 1/2. So I would say, are they the same? No. So no short way to do that other than to just do all the pieces. Find the point by plugging 1 into the function. Find the limit by trying to do direct substitution. Factor, cancel something out, but only if it was 0 over 0. Okay. Just out of curiosity, was that the one I misfactored on the answer key? Okay. I need to re-upload that, so. Yes.
I'm not going behind, but you can do number 10.
We've already done question 10. There's a video on the website you can watch. Okay, others that we haven't already done?
Did you see?
part C. Okay, so some of this is a little bit more concrete. This is referring to a point. When x is -2, y needs to be -3. All the rest of the stuff is limit stuff. So let's try, as it approaches -2, it's supposed to approach a y value of 4. So from -2, as it approaches -2 from the left and from the right, it needs to be approaching 4. I need to make that an open circle though, because I already know it's being hit down here. You okay with this matching up this clue? You okay with that? Okay. This clue says if you come from the left side of 2, the graph should be going down to -infinity. So as you approach 2 from the left, it should be shooting down to -infinity. This part says if you come from 2 from the right, it should be going up to +infinity. And the last clue is as x gets really small, so the far left of the graph, y gets closer and closer to 0. So I tried to make all this a little bit different colors to help you see what's going on here, but all we really need to do is connect these. So the stuff in gray doesn't really matter, but I've got it going to this point like they asked in red. It's got this limit that it asked in black. It's got this limit down to -infinity in blue. It's got this infinity in green going up to infinity. Notice here's their vertical asymptote. It's going to infinity and -infinity. And at the far left of the graph, it's approaching a y value of 0. So that's one possible answer. There's many correct graphs that would still work though, as long as all those clues are going to work. Okay, so to finish up class today, again, double check or add to your homework. If you have any late incomplete work, make sure that you do that because it's your last chance for points on that. I will take up 11, 12, and 13. 11 and 12 should be completed. Honestly, 13 should be too, but I understand if you're still working on that one, so you're welcome to turn all those in Google Classroom, or you can turn in the hard copies when I see you before we start the quiz on Tuesday. Any questions, just general questions about the quiz or anything that you want to know about that? Okay. So my puzzle that I have to share with you today, did we do the Rubik's Cube race last time?
Yes.
That was the last one? Okay. All right, the puzzle I have for you today is actually a little bit more challenging. This is a logic puzzle. It's not an easy logic puzzle, but it's also not as hard as it looks. It's also a pretty rewarding one. So if you like logic puzzles, if you stick with it long enough to kind of get over the initial hump, then I think you'll like that one. And I'm sharing the solution video and explanation on Google Classroom if you one thing that my other classes didn't immediately understand, again, you can't do this one quickly, but this part right here, to have a chance at it, you need to make sure you read that carefully. If you buy 2 hogs, how much do you pay? You pay $4. If you buy 1 hog, it costs $1. If you buy 2 hogs, it's $2 each, so it's $4. If you buy 3 hogs, it's $3 each, so it's $9. If you bought 10 hogs, they would be $10 each, and you pay $100. So if you don't factor that part in, then it won't work. And the only other hint that I'll give you is that you have to try to come up with an equation or two, and then it's not too bad. I promise it's not as hard as it looks. Any suggestions on how to start it?
Could you smell this?
Yeah, I have to look this up. You still on the swimming team?
Yeah.
Miss you doing that still? Last year she told me about how hard it was for y'all to find a good place to practice.
Oh, yeah, we're at the Jones Center every day.
Oh, y'all found something?
Yep.
You made an A in pre-cal?
What?
You made an A in pre-cal?
I did. Hopefully I do in this class.
Your brother didn't tell you how hard it was?
With this one? No, he didn't. I know what he got on the AP exam, but so.
How did he do on the AP exam?
I mean, he passed, but I don't think he did it as well as he wanted to. and my goal is to get as high as